Today we're going to be looking at what we call volumes of revolutions, and these are very easy to do. One of the most important things to remember is that we will be revolving a shape around an axis. Okay, so we're going to revolve about an axis. For example, let's say we want to revolve this function, the function f of x, about the x-axis. So we draw like a little circle going around there to show that that's what we're going to revolve it about. We call this axis the axis of revolution. So what you got to kind of imagine, kind of picture, if I were to revolve this function on the x-axis, I would get kind of like a cylinder. On the opposite side, it's going to be kind of going down like so. And I would get a shape that looks something similar to that. Now the question, kind of like I said, a bent-in cylinder. The question is, how do we go about finding that volume? Well, the answer is very simple. It's very similar to what we're doing in the area. We're going to take an area and revolve it, and that's all we're doing. So to solve a volume of revolution is very much the same as solving an area problem. We start with a rectangle. From the very top of my function, I'm going to draw a rectangle to the axis of revolution. We'll talk about what that means in just a few moments. And what I'm really going to do is I'm going to revolve this rectangle. Now, if I revolve a rectangle around an axis like so, think about what we're going to get. Almost like a coin, a very skinny cylinder, a coin there. We call this the disk method. And it's very simple to do. Whoops, can't spell method today. We call this the disk method. So what I'm going to wind up with, if I revolve this, is I wind up with a very skinny disk. And if I draw my disk on the outside, like so, this is very simple, I can find its volume. For example, this has a thickness dx because, again, it's vertical. Remember, in this case, we're going to have a vertical disk. And I can to find the volume now, the only other thing I really need is the radius. Well, there's my axis of revolution. In other words, the x-axis. There's our axis of revolution. Well, how do we find the radius? Well, very simple. The radius is just the distance from the function to the axis of revolution. And that's really how we define the radius here. So there's my radius. Now, because it's vertical, it is top minus bottom. In this case, it's just going to be f of x minus 0. Later on, that's going to change a little bit for us. So if I want to find the volume of my one disk, it's very simple. It's pi r squared times the height. So to find the volume of my one disk, it's going to be pi. My radius, which we just said was f of x squared, and the thickness, the height, dx. And that's the volume for one disk. To get the volume for all the disks, our formula, we take the integral. Pi times f of x squared dx, and we're going to integrate that from a to b. Now we can factor the pi out, which we will do later on. So let's take a look at a few examples here, okay? And I got some examples kind of ready for us. So there's our formula, find volume of revolution. So I have a few examples set aside, so let's take a look at some of them. That was a bad mess up there, so let's take a look here. We want to find the volume of the solid by revolving this parabola and these line segments about the x-axis. We want to find the resulting volume. So I start with drawing the bounded area. It's my parabola, 9, there's minus x squared. It crosses at negative 3 and 3. X equals 0 and y equals 0. There's our x and y axis, kind of mix them up, and x equals 3. So I'm looking at revolving this region about the x-axis. Alright, so I need to draw my rectangle. Well, remember, drawing your rectangle, I'm starting with my function, and I measure to the x-axis, just like what we did when we want to find area between two curves. Okay, it's very similar to that, except what the difference is when I revolve it, now I'm going to get my cylinder. So I'm going to draw my disk. There's my axis of revolution, the x-axis in this case. It has a thickness dx. And now all I got to do is get the radius. Well, this is my radius. So, real quickly, let's define what the radius is. It's the distance from the function to the axis of revolution. That's how we define the radius. So in this case right here, because my line is vertical, my rectangle is vertical, it's going to be top minus bottom. The top is my parabola, 9 minus x squared, minus the bottom, which is 0. So therefore, it's just going to be 9 minus x squared. And there's our radius. I want to find the volume. The volume of my one disk, very simple, pi, times my radius, which is this 9 minus x squared, times the thickness, dx. There's the volume of this one disk. To get the volume of all the disks, I take the antiderivative. Now pi is a constant, so I can take that out, and I get this 9 minus x squared dx. And we're going to integrate that from, and remember, we're vertical, so we can go from starting at 0, going all the way to 3. And that will give you your volume. Very easy to do. So let's calculate this on our calculator to see what we get here. If I want to simplify that one, I would just go turn on the calculator. Hello, calculator. There we go. Oh no, that one's taking a long time to turn on, so it needs to charge up. So let's try another one here. Turn this one on. There we go. Enter. If I type this in, menu, calculus, numerical integral. Now I would go from 0 to 3, and I type this in, 9 minus x squared dx. I hit enter, and this gives me 129.6, don't forget the pi, units cubed. And there's our volume. Now, what if we want to go about the y-axis? Well, it's the same graph, so that's not too hard to do. But this time, remember, I'm only interested really in the first quadrant here, so I'm just only going to draw the first quadrant. I'm still looking at the same region, but this time, if I want to go about the y-axis, our rectangle now is horizontal. Now, hopefully you remember, if it's horizontal, we have to be in terms of y. So I'm going to go ahead and solve for y here. So solve for x. So I got y equals 9 minus x squared. X equals plus or minus the square root of y minus 9. I only want the positive one because I'm in the first quadrant. So there's our equation that we're going to be using in this case. Sorry, it should be 9 minus y. There we go. Oops, algebra error there. There we go. It should be 9 minus y. So when I draw my disk, because now when I revolve it, my disk is going to be horizontal. So I draw my disk like so. dy thickness. There's my y-axis. And there's my radius. So the volume of my one disk, very easy, is pi times my radius squared h. But I got to find my radius. Because it is horizontal, it's going to be the right minus the left. On the right is my parabola, which we solved for, the square root of 9 minus y, and the left is 0. So it's just the square root of 9 minus y. So therefore, it's volume of my one disk then. I can replace pi times my radius, the square root of 9 minus y, squared dy. Or, to get them all, pi, I'm going to take the integral of 9 minus y dy. But now I need my domain. Be careful, we're going up and down this time, so we're starting at 0, going all the way to 9. Keep everything in terms of y. And that's how we find the volume of a disk. On part 2, we'll do the washer method.